Hello, dear learners. Good morning. I am Teacher Stella and welcome to a day that's filled with fun and learning. So get your ballpen, paper or notebook, and your self-learning modules in Earth and Life Science for Quarter 1, Week 3. Today, we will just focus on this most essential learning competency, which is to describe where the Earth's internal heat comes from. So our lesson today focuses on the Earth's internal heat. Now, are you ready, learners? Of course, yes! Now, take a look at this picture. What is this? Yes, heat! And you know, heat energy plays a vital role in our planet. It is one of the extreme factors that what makes the world livable. If you think of a volcano, you know, Earth must be hot inside. The heat inside of our planet moves continents, builds mountains, and causes earthquakes. But where does all this heat inside the Earth come from? Before we'll answer that question, we will have first an activity to exercise our mind. Write real if the statement is correct and real if it is not. Okay. Number 1. The solid portion of the Earth is made out of rocks and minerals that could experience changes, either physically or chemically. The answer is real. Very good. Number 2. Weathering is also known as the breaking down of rocks. The answer is real again. Number 3. Water is the strongest agent of erosion. The answer is real. Correct. Of course not. Water is not the strongest agent of erosion. Okay, let's proceed to number 4. Due to rusting, the rock became brittle and later broke into fine particles. The answer is real. Yes, correct. Now number 5. Weathering, erosion, or transportation, and deposition are endogenic processes. The answer is real. Yes, it is real because weathering, erosion, or transportation, and deposition are examples of exogenic processes. You've got perfect? Wow! Since ancient times, human beings have sought to understand the formation and composition of the Earth. Several theories emerged about the origin of the Earth and its proper makeup. As scientists say, there is more the Earth than we can see on this surface. In fact, if we were able to hold the Earth in our hands and slice it half, we would see that it has multiple layers. Now, with your ballpen and paper, you are going to draw the layers of the Earth, label it, and then encircle the hottest portion. have a nice drawing and you have encircled the hottest layer of the Earth, which is the core. Very good. Since you did great in your activity, you deserve to learn more about heat of the internal of the Earth. Earth receives heat from the sun, but aside from the sun's heat, we also feel the considerable amount of heat coming from below, the emanating deep within the Earth. This heat also drives important geological processes at just the moment of the tectonic plates and the flow of magma near the surface of the Earth. The Earth is divided into three main layers, and these are the core, the mantle, and the crusts. Each of these layers can be further divided into two parts, the solid inner core and the liquid outer core, which is composed primarily of iron and nickel. Then upper mantle, which is partially molten, or we called it as phenosphere, and the lower mantle, which is the liquid portion of the mantle, and this is composed of iron, magnesium, silicon, and oxygen. The thinnest and the outermost layer of the Earth is the crust, and divided into two, the oceanic crust, which is composed of basalt, and the continental crust, composed of granite. Each temperature increases with depth, but not at uniform rate. This is called the geothermal gradient, which refers to the rate of increasing temperature with respect to increasing depth in Earth's interior. Earth's geothermal gradient is 15 degrees to 30 degrees Celsius per kilometer within the crust. This figure shows that the geothermal gradient in each layer, as you can see in the graph, the temperature gradient within the lithosphere varies depending on the tectonic setting. Gradients are lowest in the central parts of continents, higher where plates collide, and higher still at boundaries where plates are moving away from each other. The Earth's crust has an average thickness of 8 to 40 kilometers and with an average temperature of 14 degrees Celsius. This temperature vary, for example, in coal mine situated at depth of 1.5 kilometers. Its temperature is of about 36 degrees Celsius. In some South African mine, the temperature at a depth of 3 kilometers is about 50 degrees Celsius, and at a depth of 13 kilometers, the temperature is as high as 200 degrees Celsius. So below in the crust is the mantle with a thickness of approximately 2,900 kilometers and has approximate temperature of 3,700 to 1,000 degrees Celsius. In here, the geothermal gradients below the melting temperature of a rock except in the atmosphere, where rocks are softened. Now below the mantle is the outer core, with an average of 2,250 kilometers thickness and has an approximate temperature of 6,100 to 4,400 degrees Celsius. Since iron melts at 3,000 degrees Celsius and nickel at 2,900 degrees Celsius, the outer core is molten and the center of the Earth is the inner core with thickness of 1,300 kilometers and has an average temperature of 6,000 degrees Celsius. But why is the inner core solid? The reason is the great pressure at the center of the Earth, reaching 100 billion pascals, The pressure forces the iron and nickel atoms together, keeping them in crystalline form despite the high temperature. Convection helps to move heat within the earth. Convection current is a continuous loop of sinking hot, soft, rocky, caused by the energy transfer in the asthenosphere or the Earth's mantle. Convection creates layer of sinking of cold and rising of warm materials in the mantle. This circular pattern is called the convection cell. This carries heat at the surface of the mantle much faster than the heating by conduction. A convecting mantle is an essential feature of plate tectonics. The convection is the mantle behaves the same way convection happens in the pot soup on a hot stove. The material near the heat source becomes hot and expands, making it less dense than the materials above. Buoyancy causes it to rise and colder materials flow in from the sides and sinks at the bottom, creating cycles of the sinking of cold and rising of warm water. And now, this is how convection happens in the Earth's mantle. Try to look at it very closely. Now there are two major sources of heat, the primordial heat, the radioactive heat or radiogenic heat. The primordial heat comes from the word primordialis, which means of the beginning, which refers to the heat from the accretion and bombardment of the earth during early stages of formation, or when the earth was formed. A major source of Earth's heat is the radioactive decay, which refers to the energy released when the unstable atoms decay. The radioactive isotopes of uranium-235, uranium-238, thorium-232, and potassium-40. And the Earth's mantle are the primarily source. Radioactive decay produced energy in the form of heat, and the heat generated reaches the surface of the Earth. Now let us proceed to the importance of the Earth's interior heat flow. Number 1, formation of surface oceans and the ocean continents caused by the tectonic activities. Because of convection in the Earth's mantle, tectonic plates in the Earth's crust are able to move, creating both surface ocean and surface continents. The combination of oceans and continents established the biogeochemical cycles that allowed Earth's surface temperature to be sustained at an optimal level for life, despite of the ongoing brightening of the sun. Number 2, Earth's strong magnetic field caused by the solid core. The Earth's unique strong enduring interior heat flow enables it to have a both solid inner core and a liquid outer core, and this creates the magnetic field that shielded Earth's surface life from deadly flowing in from the sun. And that's all about the heat of the internal of the Earth. Now, to evaluate whether you understand the lesson, so let's have some activities. So, let's proceed to the fact, question, and answer portion. And now, let's proceed to fact, question, and answer portion. Okay, you just give what is asked. You may write your answers in any sheet of paper. Okay, number 1. Fact. Radiogenic heat is the heat generated by long-term radioactive decay. Question. What are the sources of radiogenic heat? The answer? 4 long-lived isotopes or the large half-life, namely potassium-40, thorium-232, uranium-235, and uranium-238. Okay, very good. You've got it right. Now, number 2, fact. In the figure that I have shown to you a while ago on how heat is transferred in the Earth's interior, the convection cell shows that the warm material rises up to the surface and cool material sinks. Now, question, what will these cooled materials eventually turn into? Yes, the answer is land formation. Correct. Number 3, fact. Heat energy plays a vital role in our planet. It is one of the extreme factors in what makes the world livable. Question, what are the 2 primary sources of the Earth's internal heat? The answer? Primordial and radiogenic heat. Very good. And number 4, fact. The types of heat transfer are conduction, convection, and radiation. Question, which type occurs at the mantle but not between the core and mantle? The answer is convection. Yes, correct. Okay, congratulations, dear learners, especially to those who got perfect. Okay. Yay! We've done with the first evaluation. Congratulations to those who've got perfect. And now let's proceed to an application. I will be the one to give a scenario, and then you are going to determine whether it involves conduction or convection. Okay? Okay. Number 1. A heater in the hot air balloon heats the air. The air inside is trapped, causing the balloon to rise. What's the answer? Yes, convection. Very good. Number 2. Chocolate candy in your hand will eventually melt as the heat from your body is released and makes it melted. Okay, the answer is conduction. Very good. Okay, another question, or can you cite an example of radiation based on one state today living? Yes. Examples are the heat emitted by a cell phone, the light emitted by an incandescent lamp. Yes. Wow, congratulations for doing great this day. According to John Baptist Joseph Fourier, heat, like gravity, penetrates every substance of the universe. Its rays occupy all parts of space. That ends our lesson for today on Earth's internal heat. Bye-bye!